Question 3. Simplify each of the following expressions. In part 1 we've got this expression, and we've got a 2 here, a 4 here, which is 2 times 2, and an 8, which is 2 times 2 times 2, which means that the prime factor here is 2. So if we expand this to represent each of the terms, 4 is 2 times 2, so 4 to the 2x is 2 to the 2x times 2 to the 2x, and 8 to the x is 2 to the x times 2 to the x times 2 to the x. Let's gather all the values of x together. We've got 2, 4, 5, 6, 7, so 2 to the 7x over 2 to the 5x. If we take 5x from 7x, we'll get 2 to the 2x, and that's the answer of part A. Now part B, we've got expressions involving x and expressions involving y. So let's expand this bracket here. So we've got e to the x, e to the 2y, e to the 3x and e to the 3x over the denominator. Gather all the terms together. We've got e to the 7x, that's the 3, plus 3 is 6, plus 1 is 7. E to the 2y from there, and the denominator's there. So now we can subtract 3 from 7 to get e to the 4x, and we can subtract minus 2 from 2y, so we'll get e to the 4x and e to the 4y. That's the answer to part 2. Right, part 3. We've got log to the base 2 of 4 to the y, and as in part 1, where the 4 can be broken down into powers of 2, we can change this so that the 4y there becomes 2y times 2y, which means that we can rewrite that as 2 to the 2y, and in effect we can take that 2y outside the bracket in front of the log to the base 2 here, which means that we then end up with log to the base 2 of 2, and log to the base anything of anything is equal to 1, which means that this expression now just becomes 2y. And then finally part 4, we've got 1/3 log a to the 27. Now 27 is 3 cubed, 3 times 3 times 3 is 27, so we can rewrite that as 3 cubed. Now because we've got this cubed here, we can bring it out of the bracket and multiply this third by 3, which means we get 1, leaving us inside only log to the base a of 3, which is the answer. And that's the end of question 3.